Now we're going to start a new chapter, Binomial Theorem. So as the name suggests, binomial. So we are doing something with two terms. Let's see what exactly the objective of this theorem, or what are we trying to learn in this chapter. If I take any two terms, say x and y. Okay. So our whole objective is raise it to some powers and try to figure out what are the terms we get in the expansion. That's it. For example, if I say x plus y whole square, we all know it's x square plus y square plus 2xy. But suppose I raise it to the power of 10. Do we know what are the terms there? What are the coefficient of the terms there? So that's what we are going to try to figure out. So we'll start with the simplest powers, right? So say x plus y power 0. Y start with 1, then we can start with 0. So this is nothing but 1, because we know that as long as a power 0 is always 1, as long as a is not 0. Right? Now what about the next term, x plus y? So x plus y to the power of 1 is x plus y itself. See, we're still dealing with only two terms. We sometimes use three terms, etc., but the logic is the same. So we are using this expansion for the application of higher terms. Okay. Now, when we talk about x plus y whole square, we all know this. It's x square plus y square plus 2xy. Now, I can write this in different ways. I can write it as x square plus 2xy plus y square. Or I can start with y square and so on. But first of all, how do we get this? Where do we get x square and y square? And where do we get an extra 2xy term? If you remember, whenever we are in smaller classes, we usually tend to make this mistake. So x plus y whole square is nothing but x square plus y square. And slowly we realize that there's some extra term which comes out. So where does it come out from? What is x plus y whole square? It's nothing but the product of two terms. So when you're probably learning the product of polynomials, right? Multiple terms, like product of two binomials, you would have come across. So look at this. This is nothing but, okay, you can use the distributive property and write it as x plus y into x plus y. So basically, you have to multiply each of the terms, right? So this is nothing but x square plus xy plus xy plus y square. You can always interchange x and y. So yx is nothing but xy, plus 2 into 3 is nothing but 3 into 2, right? So this is nothing but, we get our terms x square plus 2xy plus y square. So if you see the entire binomial theorem, or any of this product, even higher power, it need not be 2, 3. It can be even 10. You can always figure out by multiplication. You can simply sit and multiply all the terms, and you can still get your answer. Obviously, if there's a formula, it's much easier to do so. But it can be done. A time-consuming process. That's it. Now, what about x plus y whole cube? Many of you might already know this, but let's try to find out. Let's not keep it as a formula. Let's try to multiply and figure out what is this value. Now, there are two ways we can multiply. Either I can multiply from scratch, right? I can always take this as x plus y into x plus y into x plus y. If I do that, how do we multiply? Three binomial terms, right? So this x, let me just figure out. This x, I have to multiply with x. Or I can use the distributive property, but let's directly multiply every time instead of writing the whole expansion. With this x, first I multiply with this x and with this x. Then with the same x, again to this y. Right? Makes sense. Now I just covered this x. Now next part would be this x with this y and this x and the same y with this y. Right? That would give me, say, two terms each. Next, I have covered x and y for this x, and for each of this x, I have covered x and y. So my x is covered. Now we'll start with y. So y into x, then the same x into y. Same procedure. Again, y into x. We know this. I'm just trying to recall the process. So I'll write it similarly, right? So that there's no confusion. So first I'll multiply all the three x. I'm just writing x, x, x. That means x cube. That means the product of the three terms which I just mentioned. Right? Okay. Next term would be what? As I said, it will be x, x, and y. Okay, I'm writing in the same order. Now, x and y now. So x, y, and x. X, uh, sorry, yeah. X, y, and x, then x, y, and y. We're done with, we're getting only four terms. So from x, now four terms from y. So it will be y, x, and x, y, x, and y, y, and x, y, y. Now, because this is a product, this is a product of three terms, right? So we know what is x into x into x. It's something called x cube. Okay, what is the next term? That's x square into y. The next would be, see, I can write this x, y, x as x into y. It doesn't make a difference. So it's again x square into y. Next would be x into y square. I'm trying to keep x first and y second, right? So that I can see the like terms easily. So this is y into x square, but it's nothing but x square into y plus x into y square plus y square into x. Okay, let me write x first. X into y square plus y. Now we know we can add like terms, right? Let's look at it. So this is x square y, and x square y. 3x square y's. That's x cube plus 3x square y. What will be next term? Xy square, xy square, x square. So it's 3xy square. Okay. Some of you might know the formula already. So you wouldn't write in this form. You might write something like this. Say, you might write it as x cube plus y cube. Say, there's 3xy common in the rest of the terms. If you just notice. If you notice here. So in these two terms, you can take something common, which is 3xy. If I take that common, you get x plus y. So you may say that to remember this is much easier. It's x cube plus y cube plus 3xy into x plus y. But we'll stick to this. I'll tell you why. Okay. We try to stick to these standard forms. Okay. One of the main reasons why I want this is, suppose I ask you what is the second term of, say, x plus y whole cube. Okay. One of you might answer this term. In your book, somebody might have written in a different way. You might answer this term, right? Somebody might answer this term. Somebody might answer this term. There will be a lot of confusion. Okay, so we'll stick to that. Stick to a particular rule, and we'll try. So whenever I say second term, so everybody is on page, right? Let's see what is the second term, and how do we get it? So what I'm trying to do is, right? If this is x, I'm writing the highest power first. Okay, highest power first. Second would be the second highest power of the same variable because it was x initially, and now again it is x squared. Okay, there is x. Now here you may say it doesn't contain x. It's nothing but x power 0. Correct. If you want to write in y, it's the other way. Look at this. This is y cube, y square, y square. Okay. So I'll try to write that way so that whenever I say second term, there can't be any ambiguity. Right? It will always be same for everyone. Okay. So what are we trying to do? We figured out x plus y whole square, x plus y whole cube. Obviously, next is x plus y whole power 4. But before that, I told you we can multiply it in two ways. So what is the way we chose? We chose to multiply this directly from x plus y. What if I simply take this as, say, x plus y into x plus y whole square? What I mean is, we already know what is x plus y whole square, right? So let me use that. So x plus y whole square is nothing but x square plus y square. Okay, let me stick to the same form, which I told you. So 2xy plus y square. Yes, we can do that here. And if you multiply, so let us quickly multiply and finish it off. So this is x into x square, which is x cube, x into, first I'll just show you, I'll multiply this first, this. Then I'll go here, right? And we'll complete the problem. So it will be 2x square y, again x into y square, so x square. Now multiplying the y terms. So y into x square. So it's x square y plus 2x y square plus y. Again, if you add them, you can see you're getting the same term 3x square y plus 3xy square plus y. Look at this. We're getting the same thing. So what I did, we already had that information of x plus y whole square. So we try to use it and this multiply. So whenever I'm trying to find the next term, we can always use the previous information. That was the advantage. Say x plus y whole power 4. I can always do it as x plus y into x plus y whole cube. Because I just know what is x plus y whole cube, right? So trying to use it, and otherwise you can always multiply. Just multiply 4 terms. There'll be a lot of terms to add, right? So it's easier to multiply this because we already know the result. So let's try for x plus y whole power 4. What do we get? Okay. So x plus y into x plus y whole cube, which we know as x cube, plus 3x square y plus 3xy square plus y. If I try to multiply, again, I'm going to multiply x terms first, x into all of the 4 terms, then I'll multiply y into all of the 4 terms, right? This is what we're going to do. So it's x power 4 plus 3x cube y plus 3x square y square plus xy cube. We're done with the x terms. Now y terms. X cube y. I'm trying to write x first. So next is 3x square y square plus 3xy cube plus y power. This again adding the like terms. So x power 4 is here. So this is x cube y. Is there any other x cube y? Yeah, there's x cube y here. So it's plus 4x cube y. Next, 3x square y square. There's 3x square y square here, 3x square y square here. So 6x square y square plus xy cube, xy cube. 4xy cube plus y power. Okay, we got x plus y whole power 4 already. I know we don't usually remember this formula. We don't need to remember, right? We can always get it pretty quick. So can we find x plus y whole power 5? Yes, we can. We can again multiply the same what result we got with x plus y. That's fine. What about x plus 8? Sorry, x plus y whole power 8. Again, we can do that, but it will take some time. What about x plus y whole power 20? Some more time, right? So instead of blindly multiplying, correct, we want to try to figure out a way. If you give me x power y whole power 20, I can write all the terms. Okay. Before going to that, how to figure out what are the terms, let's try to analyze what we got. Okay. So this is purely a purely a algebraic interpretation of what this multiplication is. You can think about it geometrically as well, because I'm certainly sure you would have seen, say, let me write it here. Okay. You would have seen x plus y whole square equal to c square. In Pythagoras theorem, somewhere you would have seen some proof using geometry, right? Something like if this entire square is say x plus y. Okay. So assuming this entire length is x plus y. Okay. So what is this x plus y whole square? Nothing but the area of this, right? X plus y into x plus y. Okay. Now certainly x is smaller and y is smaller than x plus y. Let us just take some particular value for x. Say suppose this is x, right? This is x. Okay. So if this is x, you can see that area what I drew right now, this entire area would be x square. Okay. Now look at the remaining part, because the entire length is x plus y. This remaining part here, let me change the color. Remaining part here must be y. This must be y. So similarly, if I add here, you can see that this is y. Same logic. Okay, it's a square. So this is nothing but y square. So you're saying that this is y square and this is x square, right? This is x square. So you can clearly see there is some area missing. The entire area is x plus y whole square. And we're saying this is x square, this is y square. There is some terms missing. Okay. So let's figure out what is the area here. Let me use some other. So this length is x, this length is y. So this area is xy. Again, similarly, this length is y, this length is x. So it's a rectangle. So the area is xy. So what do we get? What do we get? We get this is x square, y square is xy plus xy. You can see that it's the same thing what we got here. It's nothing but x square plus 2xy plus y square. This is not only for 2 dimensions, right? Because we had x plus y into x plus y, we're thinking in 2D. We can extend this to 3D as well. Okay. There will be little more involved, like we have to consider a cube. Let's try that. Let's see what it means. So if I draw a cube right now, okay, let's look at this. Now we are talking about this entire thing is x plus y whole cube because we know the volume of a cube is nothing but a cube, right? So if each of the side of this cube is x plus y, so if each of the side is x plus y, so the volume of this cube will be x plus y whole cube. But somehow, I have to show you that this whole cube is nothing but x cube plus y cube plus 3x square y plus 3x y square. This is simple, I think. We can just, like last time, we can simply just break down into some particular cube and let me try to do that. So this part, this much is x. Okay. Some random number. So we don't know what the value is. But this part is x. So look at this. Now we are not talking about 2D square, we're talking about a cube, right? So it should go inside. So somewhere here, somewhere along these lines. Right? Yeah. Somewhere like this. There will be a cube here. So let me try to shade it. So this entire cube you can see, right? Even in the back side, it would go behind. And that cube, if I complete it, it might get complicated. So stop there. Okay. So you can imagine now, right, that this cube is nothing but x cube. Now because the length is x, y, x plus y, the remaining part should be y. So I'll try to use the same color. So let me use blue. So this part should be y. Correct. Similarly on the other side, it may not be stopped here. Look at this. Let me just join this line. Even this part is y. Even on the height wise, look at this. Even this part is y. So I can draw a cube here, just so that it's much more easier. I'll just draw the cube at the end. Let me try to draw it with white lines. So look at it. I'm just going to draw a cube here. So this side, what I get, you can imagine. So I can take, because y is small, so I try to draw a smaller cube, right? Now this entire cube here, I know the other side. Probably has to be a little bit bigger, just to seem like a cube. The corner part there, which is similar to the sides, yeah. And actually, this x and that y would be joining there, right? On the back side, if I just join these two parts here, you can see there's still a lot of area remaining. Okay. So what are these lines? Let us see what it is. So we came across this is y cube. Let me write it down. So this would be y cube, right? Volume of this cube with side y. and here you would get x cube. This is x cube. So what would the remaining side what we get? Okay, look at this. Now this length, let me try to use green. Okay. So now there is some part remaining, right? In front this. Yeah. So what is the length here? Now look at it. This should be x. This length should be x, right? Because we are talking about there was y. The entire length is x plus y. So if this is y, this should be x. So this is x. This is y we know because this is y, right? And what about this length height? This is also y. So this is x. Let me try to draw in the same color. So this is x, this is y, and the height is again y. So we got xy square. Can you see that volume? So you've taken care of this entire volume now. This much. Yeah. Similarly, same logic, same logic. If I apply on the other side, look at this. Here. Okay. Now you may not be able to see the entire thing. Okay, it might be a little difficult to imagine, but still we can try. So what would be this length? This would again x, because you can see that it is a similar projection, right? X. What is this length? This is y. And the height again is y, because we're talking about a little here, so this would be y. So again, it would be xy square. One more xy square. Okay. Now look at it. We had 3xy square. You can figure out the third one. Look at, if I draw this below here. Again, you're getting the same thing. You're getting this length as x. This is y, and the width here you will again get it as x. Okay. So you can complete this figure. You can figure out all the remaining parts. So there are 3 parts with xy square as well, because x is bigger. So this is x square y. You can see that. Look at this part. So this length is x. Even this length is x, because this entire area is nothing but a square with x square. Right? And the height is y square. So up to this it will be y square. Look at this figure. So this is nothing but one of the x square y terms. Okay. Similarly, if you try to figure out this side, just beside this square, up to here, right? This would be the other x square y. So you can imagine that geometrically, you can see how the cubes and cuboids fit together, right? So entire term would be x plus y whole cube. Now you may ask, what should I do with higher powers? You need not stop here. You can always continue. Look at this cube. You can always extend this cube ahead, right? That can be the another dimension. But you can stop here. It will get more involved and more complicated. And to imagine the exact figures would be much difficult. Okay. You can always extend this like this. See, this entire cube shape. Imagine having multiple cubes in a line. That can be a x power 4, right? X power 4. Anyways, we have seen the algebraic part. We've seen the geometric part. Let's go back to algebra and see how can we figure out how to write the higher powers. If I am able to write the higher powers, like for example, x plus y or 20, there should be some pattern. We should be able to figure out, okay, from x cube, I got this x power 4. So there should be some logic to get x power 5. There should be some logic to get x power 6, and so on. So let us look at a famous triangle known as Pascal's triangle. Okay. And we'll try to relate what exactly this triangle is. So I'll just write down some numbers and we'll try to figure out what it is. So this is 1, 1 and 1. So these are numbers, okay? So 1, 2, and 1. Some of you might have already guessed it, but still. So 1, 3, 3 and 1. Okay. How am I writing these numbers? If you have interest, okay. So let me try to give some analogy here. Look at this. I'm just simply initially I wrote this 1, okay. Now I'm continuing this 1 across this line, right? Across this line, just continuing this 1. In between, what I'm doing, this is I'm adding these two numbers. I'm adding these two numbers and writing it. Okay, either way you write it. Now look at this. 1 plus 2. 1 plus 2 is nothing but, so I'll write it plus here. So it's clear. 1 plus. Similarly, 2 plus 1. 2 plus 1 is nothing but 3. Right? At the end, obviously, I can't add. If you want to imagine, you can think there's 0. Then it is simpler, maybe. Right? You can think like that. But either way, you can simply write down the ones. Now, using the same logic now. So this is 1. Now 1 plus 3 is nothing but 4. 3 plus 3 it is 6. 3 plus 1 is 4 and 1. Just checking once again so that I have written down right. 1 plus 3 is 3 plus 3 is and 3 plus 1. Have you seen this number anywhere before? Right? I'll write one more line, then we can figure out where have we seen this number. Right? It's somehow we can think of. This is 1, this is 5, 1 plus 4. So 4 plus 6 is 10. This is also 10, this is 5, and this is 1. Okay. Now, if you had noticed all the results till now, look at this. This is nothing but, say, this is x plus y whole power 0. Right? So look at this term. This is nothing but x plus y. Here, it's x square plus 2xy plus y square. Look at the numbers and the coefficient, they're matching something, right? Here again, we would have say x cube plus 3x square y plus 3xy square plus y cube. Next, x power 4 coefficient, so x power 4 plus 4 x cube y plus 6x square y square plus 4x y cube plus y power. Somehow we simply added these coefficients, right? We just kept adding this coefficient and we got something similar to what we had. Okay. Now we can do an exercise. We know how to find x plus y whole power 5 by multiplication. Try that. I'll just guess using the pattern we found just now. So I'll tell you what answer you have to get. You just cross check whether you're getting that answer. Just multiply and figure out. Okay. So you should get x power 5 plus 5 into x power 4y. See, I'm writing in the decreasing order. Okay. So x power 5 then x power 4. Next is 10 into x cube y square. Next should be 10 into x square y cube. Next should be 5 into x y power 4 plus y power 5. So you can multiply. You multiply and see whether you're getting the same terms. See. So this is nothing but known as the Pascal's triangle. Right? So you can see the order. Obviously, you can keep extending. Now, one more question. Again, how to find x plus y whole power 20? Should I write the triangle every time? What about 40 then? What about 60? Shall I keep on writing the numbers? Probably our book is not sufficient to do so, right? So is there some other way? We'll come to that. We'll come to that later. But let's try to figure out why are we getting this? Why are we getting 2 here? And simply by adding the numbers, why are we getting the next line? Somehow we are adding the previous number and we are getting the coefficients of the binomial expansion, right? So we just found out x plus y cube. See, it's something related to multiplication. We are doing nothing new, right? So if you look at this, this is nothing but the product of this term and x plus y. Okay. But adding what you're doing, you're just multiplying this 1 and 1. Look at this. This is x cube. This 1 and 1 would be y square. That's it. Correct? So if you want, let's multiply it here. Let's see once more. X plus y into x square plus 2xy plus y square. So what we're trying to do, we're just showing how the multiplication works. So x into x cube is x cube, x into x square is x cube, and y into y square is y cube. So taken care of this once. Look at this. This is 1. That's why it remains constant. At the end, whatever the power is, like x power 7, next when you multiply with x, it will be x power 8. Nothing changes. So this remains constant. Now look at this. We're saying we're getting 3. How are we getting from 1 and 2? See, it's the same terms what we get. Look at the terms what we get. So when you multiply x into this, okay. So that is what? 2x square y. Fine. Now when you multiply this another term, I multiply this and this. There's y into x square. So this is giving you x square. While multiplying, you actually get those terms because this is nothing but this term. Okay, correct. And there's one more term. So when I simply add the coefficient of this term and this term, it's sort of multiplication itself. Okay. So basically, what you're doing, you're adding the coefficients up. right? So because that is the maximum coefficient which we can get, because we are getting 2 from here itself. So we are multiplying it to x and y. There's no additional coefficients that can come. It will be the coefficient of this will be always 1, right? So that's how you get these terms. So if there is 2 and 3 here, so when you multiply here, you might get 2 plus 3. That's it. That's the maximum value which you can get. Okay. Anyways, you need not remember all those things. I'm just, if anybody was curious to know why are we getting these numbers, so just an intuition. So you can see and try to figure out on your own. So to know the entire expansion in general, say for x plus y whole power n, we should know a little bit of combinations. That is, in the chapter of permutations and combinations in counting, you might have learned. Just to recall, right, what is combinations at least, that is choosing R objects from N objects. So usually written something like this, NCR, or we say N choose R, right? So this is, in some textbooks, you can see something like this also. This also means the same thing. Or probably sometimes you just see CR, right? Whenever it is only CR, it's understood that we're talking about N objects. If it is anything like more than N objects, it's written as N plus 1 CR or something like that. Okay. So what is this NCR equal? How do we choose R objects from N objects? So we have a formula for it. So we say that it's N factorial. Okay. I hope you know what is a factorial. N factorial divided by R factorial into N minus R whole factorial. Okay. Similarly, there's permutations. We will not get into that. That's a separate chapter altogether. But this is a formula. So for example, if I have to find say 7C3, I simply try to do that in the formula. So it's 7 factorial divided by, say, 3 factorial into 7 minus 3, which is 4 factorial. Directly write it as well. So what is 7 factorial? We know that it's product of all the numbers from 1 to 7, right? 7 into 6 into 5 into 4 into 3 into 2 into 1. We need not write into 1 because it's the first time we're doing it. Let's try it. So this is 3 into 2 into 1. Then we have 4 factorial. Again, 4 into 3 into 2. It's a division. So we can see that we can directly cancel off these terms. Right? So it's the same, right? 4 into 3 into 2 into 1. Remaining 3 into 2 is nothing but 6, and the 6 will get cancelled. So what we are getting is 35. Right? So out of the 7 objects, if I choose 3, I can choose it in 35 ways. That's how we say it. Right? A couple of things here to know that. I think even if you have, say, NCM, what happens? So one particular case. Right? So if you have n factorial, so you'll have, say, this is R factorial is n itself, so n factorial, into n minus n, which is nothing but 0 factorial. So if you know this, 0 factorial is nothing but equal to 1. Okay, it starts from 0. Then again, we have 1 factorial, which is 1, then 2. So 2 factorial, which is 2, and so on. Right? So definition of choosing 0 objects from 0 is considered as 1. Now, this is nothing but equal to 1. Okay. So I think just for practice, you can simply use the formula and try to figure out what is, say, n. Let's not take n. Let's say phi c0, or figure out what is phi cr, where r is equal to 0, 1, 2, 3, 4. Figure out all the values, right? But first find what is phi c0, phi c1, phi c2, phi c3, so on, just for practice. So if you have tried that, you would have got phi c0 as, say, 1. I think you would have got phi c5 also as 1. Okay. This is very important. You usually get that symmetry. And you can see that in binomial expansion also you get the symmetry. If you have just looked at the Pascal's triangle, you can see that there's something symmetric about this. And you can relate, if you already noticed, this somehow related to combinations, right? Let's come back to the values. So what about phi c2? Sorry, phi c1. Phi c1 is 5, and same as phi c4. What about phi c2? Phi c2 is 5 into 4 by 2, which is 10. So it is same as phi c2. I think we have covered all of it. You can see it's 1, 5, 10. Then again, it is 5, sorry, 10, 5, 1, right? All the different terms. I don't know if you have noticed, just showed you. So you can just write it down here. So this is 5C0, 5C1, 5C2, 5C3, 5C4, 5C5. Okay. This, if somebody wants to go and try it randomly to figure out what is the binomial expansion, this one hit. Okay. Just for some more practice, I just wanted to see if you know what is n plus 1 says C2. What do you mean by this? Okay. Now, in the previous example, we had numbers, right? You can cancel off each other. Now, when we were talking about n plus 1 and all, so you don't have numbers that will cancel out, right? But you can always write down using the formula n plus 1 whole factorial by what is r? R is 2, and this is n minus 1 factorial. Right? With n minus r. So n now is nothing but n plus 1. Okay. In place of n, we have n plus 1. So n plus 1 minus 2 is nothing but n minus 1. The numerator, I can write it as n plus 1 into n plus n, sorry, n plus 1 minus 1 is n, into n minus 1 factorial. Same way, we can write 5 factorial as 5 into 4 factorial, right? So you can see that the reason I wrote this, because you can cancel them, you can cancel this. And numerator is nothing but n plus 1 into n divided by. This, if you already know, you can directly write. Suppose we're talking about two terms, it is always this term into the next term divided by. For example, if we're talking about NC2, it is n into n minus 1 by n, the next term is n minus. For example, 10C2, n is nothing but 10 into 9 by, that's it. 9 into 5, 45. Okay. So what about 3? So NC3. NC3 is n into n minus 1 into n minus 2. A denominator won't be 2, it will be 3 factorial. Here it was 2 factorial, which is 2. It will be 3 factorial. Okay. If that is confusing, don't worry. You have the formula. You can always go back and use the formula. Formula always works. Okay? It's a shortcut of how people remember. That's what I'm trying to tell you. Okay. Now somehow try to relate what we have learned in combinations to our binomial theorem or expansion. Let's look at it. What are we trying to do? Let's look at it here. Okay. Let's start with a smaller term. It's x plus y into x plus y into x plus 1. How many, if I want to choose x cube, or if I want to get x cube, that means by choosing 3x, in how many ways can I do it? You can do it in only one way. So let me write it up. Because there are only 3x. I have to multiply all of them to get x cube. Similarly, if I have to get y cube, how many ways I can do it? Only one, right? Because there are only 3 y's. I have to multiply all of them together to get y cube. Now, with the final result, the result is somewhere here. Just look at this to get x square y. In how many ways can I do it? Look at it. So I have x, 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 right? So I can choose any of the 2x. Right? The remaining term will be y. If I choose 2x, the other term will be y. There's no other way. Right? Now I can choose either these 2x, or I can choose these 2x, or I can choose these 2x. There are 3 ways to do it. Or in other words, to choose 2x, I can say 3 choose 2. Agreed? Next, we'll try to figure out only x. Okay. If I fix the x, the y is already fixed. Suppose I say I'm choosing only one x. What can be the other two terms? It should be y. Because there are no other terms here. I'm multiplying the same term. So once I choose one, the other becomes fixed. So we'll talk in terms of x because it will be easier. And we are writing in the decreasing order of x, so it's easier to imagine. Now I want to choose only one x. How many ways can I choose? I can choose either this x, or this x. There are 3 ways again. Or in terms of combination you want to speak, so 3 choose 1. There are 3 objects, I have to choose 1. Correct. Can you relate it now? Can you relate what we are talking about? So can you see this is nothing but 3C0, because I don't have to choose any of the x. There's only one way to get it. Okay, I'm choosing. Okay. So how do we get this x cube? So I have to choose all the 3x, right? So it's out of the 3x, I have to choose all the 3x. Okay. Next, to get x square, out of the 3x, I have to choose 2x. Right? To get 3x, out of the 3x, I have to choose 1x and 3c0. Out of all the 3x, I need 0x because I need to get y cube. Okay. Now look at the coefficients and try to write. This is 1, right? This is 3. This is 3. This is 1. Do they match? Can you try to apply a similar logic for, say, x plus y whole power 4? Can you try that? Okay. Let us try in terms of x. Okay. Again, let us do that. So out of the 4x, I want all the 4x. Fine. We can talk in terms of y. Okay. Let's change this. Say, I want to show you that it doesn't matter if I choose x or y. Let's talk in terms of y. Okay. So let me write in usually we write. So how many y's are there? 0 y's, right? Okay. To choose 0 y, how many ways I can do? 4c0. How many y? 1 y. Out of the 4 y's, I have to get only 1 y. So 4c1. Out of the 4 y's, I have to get 2 y's. Out of the 4 y's, I have to get 3 y's. Out of the 4 y's, I have to get 4. It's easier to see. It's 4c0, 4c1, 2, 3, and 4, right? What is the value? 4c0, if you figure out this one. This is 4c1, 4 by 1 factorial. 4 into 3 by 2 factorial, it's nothing but 6. It's 4, so 1. Can you see the coefficient? Exactly match. Okay. We're doing the same thing using permutation and combination, that's all. Now, if you have figured out x power 5, nothing. And if you have done these values, figured out what the values are, you can already see, you already figured out. Okay, same logic again. So, how many y's are there? 0 y's. There's 1 y. There's 2 y. Out of 5 y, you are choosing out of 5 y. So, multiplying x plus y 5 times. That's 5c3. Right? 5c4. 5c4. It's nothing but the coefficient here 1, 5, 10, 10, 5, 1. That's why you can see the symmetry. Because it doesn't matter if you write in terms of x or y. If you write in terms of x, you're going to get 5c4, which is nothing but 5c1. Okay. So if you write in terms of x, 5c0, instead of 5c0, you'll get 5c5. Right? Logic is the same. You can see that 5c2 and 5c3 are same. It matches with our results. We already know these two are equal. Right? We know these two are equal. Now, for all the analysis we did, can you figure out what is x plus y whole power n? Okay. Most of the textbooks they use a and b. It doesn't really matter what variables you use. So, what do you think is x plus y whole power n? Let's try to write it down. So, this is nothing but the binomial expansion. Remember, you can to find a binomial expansion, you can always multiply. You can write through Pascal triangle. If you know the previous terms, you can multiply with the x plus y and still get it. Or you can use permutation combinations, right? So this is always easier for higher powers at least. So x plus y whole power n. So I know that the first term would be x power n. Agreed? Why? To get 0 y. So what did I do? Out of n y's, I chose 0 y's. Next, there will be a term which is 1 less than power of x. So there will be somewhere where multiplying you'll get. So multiplying n minus 1x and 1 y, right? So you'll get this. When you choose 1 y, rest of all of the terms will be x. This should be n minus 1x. However, next term. NC2, you can see where we are going with this. So x1. Next. So NC 3 into x power n minus 3 into y cube plus so on. At the end, on the other side, because this n, we can keep on writing it, will never end. So just to see if x, now x is x squared, y will be say n minus 2. Now what becomes the quotient? So it's n in nc, y will be n minus 2. Okay. Now what is the coefficient? It's nothing but nc, n minus 2. Because out of the n y's, I have to choose n minus 2, right? You can guess the next term. Next term, I'll write it down. So the next term will be nc n minus 1 x into y power n minus 1. And last term, nc n y power n. This is nothing but your binomial expansion. And you use any, say, whole number, right? You can figure out what it is. It actually works with fractions and even negative integers, but right now, at least for this chapter, just focusing on n being a natural number. Okay. So can we just try to write the formula and figure out what is x plus y whole power 5? We have done this before. We know what is the answer, but still, we're simply going to apply this. 5c is 0, x power 5. The n is 5, right? Next is 5c1, x power 4. The 5 minus 1 is 4 into y plus 5c2, x power 3 into y square plus 5c3, x square into y cube. Next, 5c4, x into y power 4. Next, 5c5, y power 5. You can write x power 0 if you like, but it is 5c5 into y power 5. Now, we know the terms 5c0, 5c1, what they mean. So, what is it equal to? This is 1. 5c1 is 5. Right? 5c2, 5 into 4 by 2, which is 10. Next term, 5c3. 5c3 is nothing but 5c2 itself, so it's 10. Let me write it neatly. So it's y cube. Next is 5c4. It's same as 5c1. And then we have 5c5, which is 1. You got the expansion. Now, anybody ask you x plus y whole power 20, you can use this expansion. There will be a lot of terms. There will be 21 terms. But you're certainly sure you can write those terms. Right? Probably need a calculator to find, say, 20c, 21c, 10, and all those things. But yeah. So in general, we have figured out what is this binomial expansion. Okay. So all the terms here, you can substitute by just simply putting values for it. Now I have taken x and y. Okay, I've taken x and y. You can choose any terms you like. Okay. Find the first 4 terms. That's enough. Okay. We'll give you find the first 4 terms of say 2x minus 3 whole power 5, x plus 1 by x square whole power 6, and x minus 2 by x whole power n. Right? First 4 terms. We just learned the binomial expansion, so we'll try to use it and expand a couple of terms. This is 2x minus 3 whole power 5. Try to figure out the expansion of this. And second, x plus 1 by x square whole power 6. Okay. Third, general term, say x minus 2 by x whole power, say n. What will be the first one? First one is 5c0 into 2x. The first term is not x now, it's 2x. So 2x power 5. Next term, plus 5c1 into 2x whole power 4 into minus 3. it is x power 4 into y. So y is not plus 3, it's minus 3. So you have to make sure you write minus 3. If it was plus, we would have written plus 5c2 2x whole cube minus 3 whole square. 5c3 2x whole power 4 minus 3 whole. No, sorry. It's not minus 2x power, it's 2x power 1 and minus 3 whole cube. Next is 5c4. It's 2x whole square and minus 3 whole cube. Then it's 5c4 2x into minus 3 whole power 4. Last term is 5c5 into minus 3 whole power 4. You not really write down the numbers, but if you want, okay, let's say 2 power 5. Do we know it? It's 32. Okay. Next is 5 into 2 power 4. How much is 2 power 4? It's 32 by 2, so it's 16 into minus 3 x power 4. Okay, you can figure out. So 5c2 is nothing but 10 into 2 cube is 8 into 9 x cube. Okay. This is again 10 into 4 into say minus 27 x square. Again 5c4 5 into 2 into minus 3, it's 81 into x. And last time would be say minus 3 power 5. So we can directly write it as minus say 243. Rest of the terms you can multiply or keep it as it is, right? We're not really interested in the numbers, but for this problem at least we'll write it down. Rest of the problem you can skip maybe. So 32 x power 5. This is minus because of this. So it is 316 that which is what? 48. Sorry. 32 48. 48 5 which is 240. 8 into 9 is 72. So it's 720 x cubed. Minus 27 into 4. How much is that? So is it 100, 108? I guess so. So 1080 square. Hope so. Next is 81 into 10. So it's plus 8 10x minus 2. I think this should be the answer unless there's some calculation. Right? Okay. Second part. I think we have never come across something like 2 by x or a by b when we are doing the binomial expansion. We have to be very careful. The powers of x will vary here. Right? Let's try a second. So it is now there are second one is okay, x plus 1 by x square. Okay. So it will be 6c0 x power 6 plus 6c1 x power 5 into 1 by x plus 6c2 x power 4 into 1 by x whole square plus 6c3 x cube into 1 by x whole cube plus 6c4 into x square into 1 by x whole power 4 plus 6c5 x into 1 by x whole power 5 plus 6c6 into 1 by x whole power 6. Right. If you want, we'll write the values of 6c0, which is 6. 6c1, 6 into x power 5 by x is x power 4. Okay. 6c2, 6 into 5 by 2, 3 into 5, 15. X power 4 by x square is x square. Next 6c3. So let's try to figure out 6c3 is 6 into 5 into 4 divided by 3 factorial, which is 6. That's 20. 20 x cube by x cube is nothing but only 20. Look at the term now. We don't have any x in it. Okay? So 64 is same as the other term. So I can directly write it's 15. 15 by x power minus 2 plus 6 into x power minus 4 plus 1 into x power minus 6. Look at the symmetry. It's very wonderful terms you're getting, right? I think in place of 1 by x square, I took 1 by x, so we'll just change the problem. Third one. Now we can't really simplify the entire term with n, but we can write down a couple of terms just to see how the expansion is progressing. So first term would be x power n. If you want, you can write nc0. So it doesn't really matter. So nc1 into x power n minus 1 into minus 2 by x. Okay, minus 2, make sure you write the sign. So plus nc2 into x power n minus 2 into minus 2 by x whole square. Then write one more term, I think. So it is x power n minus 3 into minus 2 by x whole cube. Then you can just skip and write the last two terms, which should be nothing but, say, let me write x square and minus 2 whole power n minus 2. So this should be nc n minus 2. That should be nc n minus 1 x into minus 2 by x whole power n minus 1 plus ncn, which is 1, to minus 2 by x whole power. So now we don't even know if n is even or odd to figure out what is the last term, whether it's positive or negative. But you can keep the expansion as it is, right? We get an idea how to expand. You have tried to figure out the expansion of 1 plus root x whole power 5 minus 1 plus minus 1 minus root x whole power. Okay. So you have to find out what is 1 plus root x whole power 5 minus 1 minus root x whole power 5. We'll use a binomial expansion, so we know how to expand. See, one of the term, whenever it is 1, it's very easy, because one of the terms is 1, 1 power 5, 1 power 4, 1 power 3, so on. The first term, 1. First, it will 1 power n. Okay, next term, nc. Okay, I'll write down so a couple of terms so that it will confusion. 1 power 4 into root x whole power 1. Next is 5c2. Into 1 power, I'll skip now, so we have an idea what is happening. That's 5c3 root x whole cube. That's 5c4 root x whole power 4. 5c5, which is nothing but 1 root x whole power. There is another part, we'll just skip it for now. Okay, we'll just try to simplify this first. What is this? 1 plus 5 into root x power 4. Can we see what is root x power 4? Root x is nothing but x by 2, right? So, sorry, root x is nothing but x power half. So there will be 4 by 2. There is x square. X square. Next should be what? So it is 1 power 4 into root x. So it remains as root x. So it's 5 root x. Next is 5c2. We already know it's 10. Root x square. We know what is root x. Root x is x power half whole power 2, which is not x power 1. Okay. Now 5c3 again 10. X power 3 by 2. You can keep it as it is. Okay. We need to simplify again. Next will be 5c4, which is 5. X power 4 by 2, which is x square. And last would be say x power 5. This is the expansion of the first term here. This one. Now, similarly, can we write the second term? I'll just write below it, okay, just so that we get easier connections. Look at this. Only that changes is this sign. A is, see, x is same and y is same. Okay, only that changes sign. So this will remain same. Now here we'll have a change. This will be minus root x. Okay, so this is same. Again here it's same. it's minus sign, but it really doesn't matter because we are raising it to the even power. So that minus sign really doesn't matter. If you want to keep it as it is, root x whole cube plus 5c4 minus root x whole power 4 plus minus root x whole power. Can we try to write it down the similar way here? So it's 1. Instead of plus, I'll have a minus here. Rest of the terms is alternating. That's power 3 by 2 plus 5x squared minus x power 5. So I don't have to add these terms, I have to subtract them, right? So I'll add a minus sign. Let me just write down what the result is. So if I subtract this, will cancel all the same sign will get cancelled. The other will just double. So this will be 10 root x. This will be plus 20 x power 3 by 2 plus x power 5 by 2 plus x power 5 by 2, which is 2x power 5. So the question is, which of this is larger, 1.1 whole power 10,000 or 1,000? Without using calculator, obviously, right? So now you can see that 1.1 into 1.1 is 1.2, right? So it keeps on increasing. You might guess it might be larger, but any mathematical proof we have, right? Does it increase in such a faster pace that it will reach 1,000 before 10,000? All those things. So the hint given, probably, you can use something like 1 plus x whole power 10,000, the expansion of this, to get your answer. How do you use it? What is the expansion of this? First term, I'll write the first term, is x power 10,000. There's no way we're going to write all the terms, right? What would be the second term? I think that would be a most important hint. The second term is nothing but 10,000 C1, which is 10,000. Agree? And 1 power 10,000 is again 1. So into x power 1. Agree? There are more terms. If you want, you can write it 10,000 C2 into x square and so on. You can keep it up. Can you look at the second term here? Suppose x is equal to 0.1. Why did I take 0.1? Because obviously I need 1.1, so x is 0.1. Look at the second term itself is 1,000. And rest of the terms we're just adding, however small it is, just adding to 1,000. So certainly this is much larger than 1,000. Okay, I can't say much larger, certainly larger than 1,000. Okay, we are trying to find the expansion of 1 plus x squared. Now we are talking about binomial expansion. Now there are 3 terms. What can be done? Right? We don't really have to find expand everything, but just to get an idea, what should we do if there are 3 terms? So the concept is of binomial expansion itself. What we can do is we can simply consider 2 terms, like just club this 1 plus x. We club either way. We club 1 plus x because their powers are smaller. That's it. If I club, can you see what is this? This is x and this is y. So you can use the expansion now. In place of x, is 1 plus x. It's a different thing. So what is it? First term, 1 plus x whole power 7. Okay. Second term, 7c1, 1 plus x whole power 6 into x square whole power 1. Got the term. Now the 2 terms, one is x, one is y. Y is itself a binomial term, but it's fine. You can write it down. Next, 7c2, 1 plus x whole power 5, x square whole square. And figure out what to do rest. So it's 1 plus x whole power 4, x square whole cube plus 7c4, 1 plus x whole power 5, x square 1 plus x whole square, x square whole power plus x whole 7c4 1 plus x whole cube x square whole power 4. 7c5 1 plus x whole square x square whole power 5 plus 7c6 1 plus x into x square whole power 6. Last term would be 7c7, which is 1 x square whole power 5. So really interested, you can expand, but we can stop here. Okay. So the whole idea is, even if there are three terms, right, we use the binomial expansion. Now what we do, here you look at this, you can again expand this. There will be a lot of terms and a lot of multiplication. We don't need to do that. The whole idea is you understand how to expand. So expand 1 plus x minus 2x square whole power 6 up to the first three terms. Again, we are going to expand in a similar fashion, using this as the first term and this as the second term. So this is something like x plus y. In place of plus, there is minus, but it really doesn't matter. So it is what? 1 plus x whole power 6, 6c0, 6c1, 1 plus x whole power 5, minus 2x square whole power 1, plus 6c2, 1 plus x whole power 4, minus 2x square whole square, plus 6c3, 1 plus x whole power 3, minus 2x square whole cube, plus 6c4, 1 plus x whole square, minus 2x square whole power 4, plus 6c5, 1 plus x into minus 2x square whole power 5, plus 6c6, which is nothing but 1, into 1, minus 2x4 x square whole power 6. What is mentioned? We have to find terms only up to x cube. Okay. Can we just ignore some of the terms already? We could have done that before expanding also. But if you have not figured out, let's try to look at the terms at the end. This is certainly x power 12. Right? Look at the previous term. This is x power 10 into something. It can't reduce unless we have negative powers in the other term. Right? Again, higher power. X power 6 higher power. X square whole square is still higher. So very smaller terms, that is only first term and second term, to figure out what are the terms up to x cube. Okay, obviously we'll have a couple of terms here and a couple of terms here. Let's try to figure out what it is. Now, first term, in the first term, 1 plus x, we need to expand that again. Okay, we need to expand to get x cube term. That's 6c 0 into, say, 1 power 6, I'll keep it as it is, 6c1 into x, 6c2 into x square, 6c3 into x. Rest of the terms I won't even write because we know that is going to exceed x cube. Okay. Now from the second term, okay, I'll keep 6c1 outside. Okay, and then here there is minus 2x square already outside. The only term I'm interested in between is a term which contains x power 0 and x power 1. So x power 0 term is the first term. What do you have? 1 power 5 into 6c, sorry, 5c1, sorry, 5c0, which is the same. Next term. 5c1, I'll directly write as 5 into x. If I take any other term higher than that, you can see that the product will exceed the power. Okay, so I can stop here. These are the terms. We can simplify and just write down the constant. So this is 1, this is 6x, this is 6 into 5 by 2, which is 15x square, this is 20x cube, this is 6 into, but we just multiply this inside, minus 2x square, minus 10x cube. Fine. Again simplifying, this is minus 12x square, minus 60x cube. Combine the terms, you should get 1 plus 6x plus 3x square minus 40x.